Alright, let's take a quick look at Getting Ready 3.3. So, the first couple of problems want you to find the slope of a line that goes through each set of points. So there's a few different ways you can do this. Probably the easiest way is if you have some graph paper, you simply plot the points. So we got 3, 7, so about right there, and then 5, 10, and then you simply count the rise over the run. So we go up 1, 2, 3, so it's up, so it's positive, 1, 2. So it's rise 3 over run, which is 2. That's one way you can do it. The other way is to take this idea that if you look at these points, okay, we've got 3, 7, and we've got 5, 10. So we're going from this 7 up to 10. Okay, that's what we're going up. That's the y value. So you simply go 10 minus 7. Then we also know that we're going from 5 to 3 on the x. That's the bottom number. So we go 5 minus 3. Okay, notice that 10 and 5 are in the same position first, 7 and 3. And then you just subtract. 10 minus 7 is 3, 5 minus 3 is 2, and you get the same thing. Okay, so that's one way you can do it. The other way we already did on the graph. So anyway, let's take a look at number 2. Same idea. 3, 3 would be right about there. And negative 1, 4 would be right here. So we start at the left point. And we go, well, we're going down 1. So that's a negative 1. To the right, 1, 2, 3, 4. So it would be a negative 1 over 4. Or if we're using that idea about the y's and the x's, you take one of your y's, 4, subtract the other y, and it doesn't matter which one you do first, and I'll show you that it works both ways. Okay? So, two different ways, same problem. Then the negative 1 minus the 3. Or, if you started this other way, it'd be 3 minus negative 1. The thing you have to pay attention to is that whichever point is together, the negative 1 and the 4, they're vertical each other, and the other way around. That's really the only thing you have to pay attention to. Like I can't do 4 minus 3 and 3 minus negative 1. That version wouldn't work. 4 minus 3 is 1, negative 1 minus 3 is a negative 4, which, same thing. Okay, it doesn't matter if the negative's on top or bottom. This one, 3 minus 4 is negative 1. 3 minus a negative 1, that's like plus a 4. Same thing. Okay? So for 3 and 4, that's all you got to do. You can either graph it or do it the other way. Okay, now we get to the difficult ones. This is where we're going to have to figure out what is happening here. Continue the pattern and find the recursive and the explicit. Now remember, well, let's find the pattern first. Okay? So we go from 3 to 8, 8 to 13, 13 to 8, 18, 13 to 18, 18 to 23. So what is happening here? Can we multiply a number by 3 to get it to 8? No. So it's probably going to be an addition one. Well, how do we add? What is 3 plus what gives us 8? It's plus 5, right? Well, how do we get from 8 to 13? That's also plus 5. 13 to 18. You should see the pattern that we're adding 5 each time. That's what we would call the constant difference. So if we kept going, 23 plus 5 is 28, 28 plus 5 is 33, 33 plus 5 is 38, and we could just keep going with that. Now, we've got to find the recursive function and the explicit function. Remember, the recursive is based on the previous number. Okay? So, if we're thinking about this, we could just say, the current number is equal to the previous number, and what are we doing? We're adding 5 each time, so it's just the previous number plus 5. However, we don't like to write it like that. In math, they like to use different versions. There's this one, the a sub n equals a sub n minus 1 plus 5. which is saying the same thing, that a sub n is telling us that that's the one we want to find. The n minus 1, that minus 1 is just saying it's the step before. Okay, the other way we typically see is f of n equals f of n minus 1 plus 5. Okay, you could do it that way. And that's kind of crazy notation. But the thing we have to also note is where we're starting. Okay, we have to figure out where we are starting. So we'd say, for this top one, we'd say a sub 0 equals 3. Actually not. A sub 1, sorry, equals 3. And the other one would be f of 1 equals 3. That tells us, so those two go together, those two go together. And that bottom part right here is just telling us this is where our first number is, so we know where to start. And from there, we can then keep finding the previous numbers. Okay? So that's the recursive. Now, if all you know is how to do this, that's fine too. If we can get to that point, you know, this notation is just kind of coming from that. Just remember that a sub n or f of n, that's like the current number you want, and the a sub n minus 1 or f of n minus 1, that's the previous. Okay? Now, the explicit. So let's clear some space here. I'm actually going to write this out better for us. So f of n equals f of n minus 1 plus 5. F of 1 is 3. Alrighty, so let's take a look at our explicit function. Now that's the one that's going to look more like the equations that we've dealt with. Okay, that's kind of what we're looking for here. So the way that we have to think about that is we have to think about how kind of, you know, think in terms like a T-chart. Okay, the 3, the 8, the 13, the 18, the 23 are going there. This is our first number, it's the first term. This would be the second term, the third term, the fourth term, the fifth term. So this is like your x and that's like your y. Okay, or we could call this f of x. Okay, so, or we could even, if we really wanted to, you know, it really doesn't matter which variable we choose. If we really wanted to keep it kind of along the same way as this, we'd go n and f of n. So we'd have, you know, 1, 2, 3, 4, 5. We've got 3, 8, 13, 18, and 23. Now, because of this pattern, we could go backwards as well and have the 0. Okay, and then we just have to subtract 5 from it, and we'd have negative 2 there. So there's, you know, and now what we're doing, where on the recursive, the connection was just from these numbers to these numbers. Okay, now we've got to connect this number to this number and see what the pattern is. So if I'm given the n, I can find the end result. Okay, that's kind of the difference between the explicit and the recursive. So we've got to figure out how to do that. Now, there's a pretty easy way to do it. Well, there's multiple ways to do it, I suppose. If you remember that the slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept, you have to remember that the y-intercept is when we've got 0 for x and a number for the output, for the y, for the f of x, for the f of n. Okay? If we look at ours, if we went back to 0, we've got that. So our y-intercept would be negative 2. So we'd have f of n instead of y equals some slope times n minus 2. That's where that negative 2 would come into. Then if we're trying to figure out slope, slope is just how x and y change. Well, this is like the y, that's like the x. So how is this growing as this grows by 1? Well, we're adding 5 each time. Okay? So our slope should be the y over the x, or 5 over 1, which we would just call 5. If you're not sure about that, you can test it. Well, 5 times 0 is 0, minus 2. 5 times 1 is 5, minus 2 is 3. 5 times 2 is 10, minus 2 is 8. Okay, this is probably one of the easiest ways to figure it out, because other than that, you've got to deal with some issues. Okay, it's a little bit more complicated, but using that slope-intercept form is a great way to help you figure that out. And that would be the way that I would try to suggest doing it, is just making this table with it and going from that to your equation. And if you wrote it like y equals 5x minus 2, that works for me. Okay, either one works. Well, I'm not going to be too picky on that. So notice that this 5 here shows up right here, right? And this negative 2 here shows up if we were to, put in our terms the right way. The first term, the 0 term, not the first term, the 0 term would end up being negative 2 if we went back. So there is a connection between the two. There is that connection. Let's take a look at another one. Okay, so we've got 3, 1.5, 0, negative 1.5, negative 3. Now this one with the decimal might look to be a little more complicated, but look from this to this and this to this. This is kind of the key. How can I get from 1.5 to 0? Well, I would subtract 1.5. If I subtract 1.5 again, do I get negative 1.5? Yeah, and you can use a calculator to check that. So negative 3 minus 1.5 would be negative 4.5. Negative 1.5, or minus 1.5 would give us negative 6, then negative 7.5, and so on. So what are we doing? We're subtracting 1.5 each time. That's our difference. That's the constant difference. We're doing that each time. Okay? We're doing that each time, which if you think back to that explicit formula, we were adding a 5 each time. Our 5 showed up there and there. So honestly, if we're thinking about this, if I've got this explicit equation, I'm probably going to have negative 1.5 n plus or minus something. I'm probably going to have f of n equals f of n minus 1 minus 1.5, right? Because we take the previous number and we minus 1.5 from it. That's where this number comes in. Because we keep minusing 1.5, that's basically the slope. Okay, now we've got to figure out what would be the 0th term, because the term before our first term would be what goes right there. Well, we'd go backwards. Okay, what minus 1.5 is going to be equal to 3? Well, if we just added 1.5 to it, we'd get 4.5. So our first term on this is 3 to finish that one. But for this one, it's going to be a positive 4.5. And that's really all you have to do. If you weren't sure, make a table of values. We've got 3, 1.5, 0, negative 1.5, negative 3, and so on. This would be our first term, second, third, fourth, and fifth. We're subtracting 1.5 each time. Okay. So as this one goes, we go by negative 1.5. This one, we're adding 1 each time. Well, what's negative 1.5 over 1? It's negative 1.5. That's where our slope comes in. That's what we're doing on our recursive. Then if we went backwards, we get that 4.5. That would be our Y-intercept. That's why it goes right there. And that would be the term we'd put in there first to get us to where we need to be. So there we go. Okay, now 7 and 8 want us to write the equations in slope-intercept form, so we want to get it into y equals mx plus b. Okay, so we need to just get basically y by itself, something with an x, plus or minus something. So number 7, we've already got the y by itself, so now we just need to simplify this side. Well, we're going to have to distribute that negative 4 through. So we get 12 plus negative 4 times x, negative 4x, negative 4 times negative 1, so positive 4. Combine like terms, 12 and 4 give us 16, and then just rearrange it to how we need it. So it would be y equals negative 4x first, that's a positive 16, so plus 16. And there's our answer. Okay, now number 8 is a little trickier. We're going to have to do some multiplying here. So we've got 2/3 times 6y over 1 plus 2/3 times 9 over 1, since we're dealing with fractions, equals 3/5 times 15x over 1 minus 3/5 times 20 over 1. All I did was distribute it, but since we're dealing with fractions, I wrote it out. Now, if you know about canceling, that's the easiest thing to do. If not, you just go 2 times 6, which would be 12y over 3, because 3 times 1 is 3. 12 can be divided by 3, and we end up with 4y. Okay, 2 times 9 is 18, 3 times 1 is 3, 18 divided by 3 is 6. 3 times 15 is 45x, 5 times 1 is 5, 45 divided by 5 gives us 9x, minus 3 times 20 is 60, 60, 5 times 1 is 5, 60 over 5 is 12. Okay, now we subtract the 6 to get it over on the same side. We're left with 4y equals 9x, negative 12 minus 6, negative 18. Divide everything by 4 now. We get y equals, now because we're doing slope-intercept form, it's fine to leave this as a fraction. And then 18 divided by 4, I can reduce that to 9 over 2, which if you wanted to use a calculator, that would give you 4.5, which either one works. There we go.